The James Webb Space Telescope, JWST, is a major infrared-focused space observatory, launched in 2021 through a collaboration between NASA, the European Space Agency, and the Canadian Space Agency. This stands out as not only the largest telescope of its kind, but also the most powerful, with the ability to observe the universe's earliest galaxies and analyze how stars and planets are for since becoming operational. WST has become the most advanced space observatory in existence. While JWST wasn't built to study individual planets, it recently captured the most detailed image ever taken of Pluto. Milestone was made possible thanks to its ability to observe in infrared wavelengths, which allows it to see through the hazy layers of Pluto's atmosphere. According to NASA, these new images provide fresh insight into Pluto's surface composition and features. Pluto itself was first discovered on February 18, 1930 by Clyde Tummer at the Lell Observatory in the United States. Prior to this, astronomer Purcell had hypothesized the existence of a mysterious planet X which he believed influenced the orbits of Uranus and Neptune. Tummer's discovery confirmed Lyell's theory and was officially recognized by major scientific organizations including the American Astronomical Society, the Royal Astronomical Society in the UK, and the International Astronomical Union view, which gave the object the name Pluto. Pluto was once considered the ninth and most distant planet in our solar system. However, in 2006, the I reclassified it as a dwarf planet because it failed to meet all the required criteria to be considered a full-fledged planet. According to the AU standards, a planet must orbit the Sun, be spherical in shape due to its own gravity hydrostatic equilibrium, and have cleared its orbital path of other objects. But Pluto satisfies the first two conditions. It does not dominate its orbit, hence its downgrade to a dwarf planet. Interest in Pluto has remained strong. Astronomers. 2015 NASA's New Horizon spacecraft conducted a historic flyby, significantly enhancing our understanding of this distant icy world. More recently, NASA shared breathtaking, color-enhanced images of Pluto on Instagram. These visuals display the complexity and variety of Pluto's terrain with vibrant colors used to differentiate various regions of the surface, though the colors were artificially applied to bring out geological features. These images highlighted Pluto's dramatic and varied landscape, which includes rugged mountains reminiscent of those seen on Jupiter's moon Europa, interconnected valleys and terrain scarred by ancient craters captured from a distance of 222,225 miles. One standout feature is Pluto's famous heart, a large glacier made of nitrogen and methane ice. The heart covers an area roughly the size of Texas and Oklahoma. Pluto's surface is primarily made up of ice from water, methane, and nitrogen, and it is believed to contain a rocky core with possible subsurface ocean. According To NASA, the surface of Pluto is fractured and cratered and displays a range of colors including white, tan, and reddish-brown. These colors transition across the surface with a white heart feature appearing partially visible at the top of the image. NASA tweeted an image from the New Horizons flyby, noting that it displayed Pluto's true colors, including the glacier-like. The planet spans just over 1,400 kilometers across about half the width of the United States and two-thirds the width. A further research has revealed even more fascinating insights into Pluto's geological past. Scientists believe Pluto underwent a dramatic polar shift, essentially flipping on its side early in its history by examining the coordinates of various surface features. Researchers studied the planet's internal mass distribution and found evidence of surface realignment, particularly around the iconic Sputnik western lobe of Pluto's. Oliver White, a co-investigator with the New Horizons mission from the SEI Institute in California, explained that Pluto's current orientation exposes ancient landscapes whose formation is not yet fully understood. The landscapes likely formed when Pluto was tilted differently and were relocated due to a phenomenon called true polar wonder. Among the unexpected discoveries was the presence of jagged terrain near the edge of the hemisphere observed during the flyby. These features, entirely composed of methane ice, are thought to be bladed terrain formed by climatic changes on Pluto. Distinct appearance under specific environmental conditions reveals the planet's responsiveness to atmospheric shifts. Sham Mishra Postel, researcher at NASA's Jet Propulsion Laboratory, stated that these terrains may exist in other parts of Pluto as well, indicating the rich complexity and dynamic processes at play on icy worlds. The New Horizons mission continues to analyze the data collected during its historic encounter with Pluto, uncovering new mysteries not only about Pluto but about other small remote bodies in the outer solar system. The mission team is also evaluating new targets for potential flybys as the spacecraft moves through the outer. Meanwhile, telescopes like JWST continue to provide stunning high-resolution views of planets in our solar system. Recently, JWST offered the most detailed image of Neptune in 3D. These new infrared images give a much clearer view of Neptune and its rings than has been seen since NASA's Voyager 2 spacecraft first flew by the planet in 1989. Pluto's reclassification as a dwarf planet, Neptune is considered the last planet in our solar system, is located roughly 30 times farther from the Sun. Neptune was the first planet discovered through mathematical predictions rather than direct observation. The recent infrared photos from JWST are especially captivating because much about Neptune remains mysterious, typically portrayed in deep blue hues in scientific renderings. Thanks to visible light images captured by Hubble and Voyager 2, Neptune is known as the blue giant. Appearances due to the methane gas in its atmosphere, which absorbs red light and reflects blue wavelengths. However, JWST's observations in infrared have revealed a strikingly different version of Neptune. Instead of the vivid blue seen in visible light, the planet appears lighter and more ghostly in tone. A remarkable discovery includes bright streaks and patches in Neptune's atmosphere identified as methane ice clouds. These clouds form at high altitudes where it is cold enough for methane to condense and appear especially bright in infrared as they reflect sunlight effectively. Analyzing Neptune in infrared light, scientists gain new knowledge about the planet's atmospheric makeup, cloud movements, and seasonal patterns. The findings deepen our understanding of Neptune's complex weather systems. Moreover, JWST has captured clear views of Neptune's rings, which are typically hard to detect. Although Neptune's first ring was identified in 1968, their existence wasn't fully confirmed until Voyager 2's visit. Now, decades later, JWST's high-resolution imagery unmistakably shows the planet's rings and surrounding dust bands, validating and expanding upon those earlier discoveries.